Okay, let's start. Welcome to our second info day for the second Agrarian Open Call. I'm Michael Batistatos. I'm from Democritos. Democritos is the coordinator of Agrarian. Let me share my screen. Thank you for your interest in our open call. This is the second open call, and before I uh, go to the actual content, let me tell you that your microphones are muted right now. The session, of course, is recorded, so you can watch it later on our website or on our YouTube channel. And during our presentations, if you have any questions, please write them at the chat. And by the end of the session, that we have the Q&A session, we will try to answer them. So the agenda for today, I will give you an overview of the agrarian project and the call. I did it also at the first info day, but since maybe different people have joined in today, I will say some things in order to be in line with the content that we'll describe and present later on. Then we will talk about testbed number 3. We presented the first two testbeds in our previous info day. Then we will talk about a basic component of agrarian platform, which is the orchestrator and the application repository. Then we will present you the selected projects from the previous open call, so for you to get an idea of what projects have been selected. And then again, we will give you a platform walkthrough in order to answer any questions you have about your submission. And then in the end, we will have the Q&A section. And if we have enough time, we will try real time to address any questions you may have. So let's continue. Agrarian is a Horizon Europe project in the sector of agriculture. Democritos is the coordinator. We have 13 partners from all around Europe, and we have 3 pilots in Greece, in Romania, and in Portugal. Here you can see the main concept of Agrarian. We care mostly for 3 different entities. It's the end user, the developer, and the policymakers. So what Agrarian makes a platform that integrates these 3 entities. So we would like, and this is our target, to host the developer that develops some applications for the agricultural sector, then user that uses these applications, and finally the policymakers that they can see on our decision system all the gathered and selected and collected information from wide areas of farms in order to derive useful decisions collectively. So the core of our platform is the orchestrator. We also have the application repository and the data storage. So what we vision and what we're trying to develop is to have the developer make applications, store them in the application repository, and then the end user, the farmer, through the agrarian portal can see all these available applications in the application repository, request 1, 2, or 3 of them, and the orchestrator automatically to get the application from the repository and install them near the end user at the edge of the network. The applications start to run, and the data that are produced from the application are stored in the data storage in order later on the ADSS, the Agrarian Decision System, to get this data and propose actions to the policymaker. Also, the farmer will earn from this process, as by running these applications can also receive useful data for his farm. As a connectivity layer, we have terrestrial and non-terrestrial links, like satellites, 5G systems, and of course we have embedded the last mile accelerators, like the edge computing capability in order to offload the network and make things easier and faster. So this is the generic concept of agrarian platform, and you are coming as external developers to develop applications and integrate into the agrarian platform in order your application to be used, to be handled as described before. We have 3 official pilots. You are not connected with the pilots. I'm just presenting them briefly here. We have livestock monitoring in Greece. We have crops monitoring in Romania, and we have vineyards management in Portugal. But again, I'm telling you that you are not connected. You don't need to go there. You don't need to cooperate with any of our pilot leaders. Of course, you may do that, but it's not mandatory. What we are asking from the applicants in this call is implement, so we are asking for new use cases that produce real field data. And we also need your applications. So 2 things, the developed applications, the applications that you will develop, and real field data from the farms. Why we are doing this second open call? We firstly need to validate our platform and our technology through new use cases that you will bring and new applications. And this is going vice versa also. We will offer to you the opportunity to extend and validate your applications to our platform. In total, we will have 8 winners. The funding amount is 50,000 euro fixed amount. We don't need any cost justification, and this is a question that we usually receive. This is a lump sum funding, so the cost justification is not required. You get this money, and that's it. You can spend it as you wish. Now I will tell you some key points from this new open call, because it is somehow different from the previous one, and some people, because I also watched the support email, some people they are getting confused. The implementation phase in this call is 10 months. In this open call, we can have a consortium up to 3 partners, but also a single organization can apply. We will not fund projects that have been already funded from our previous open call or from our sister project Open Agri. The selected project, as I said before, needs to bring real field data. We have this time 3 test beds, the 2 first that we already had from the previous time, and an updated version, an advanced version of the last 2 we had, and they are all combined in this new testbed, which we name it as Testbed 3 in this open call. And we are trying, our purpose is to validate the orchestration of our platform, the data repository, data storage, the test beds as edge nodes, and other elements of the platform. So here you see what you should bring, your side, what you are responsible for, and agrarian side. So the agrarian side is only our platform. So we have our test beds, are also sometimes communication test beds, our orchestration, application repository, and data storage. And your responsibility is to develop your application and to have your sensors and any equipment on the field and transmit the data through the internet to our platform. So we will not give you any sensors, UAVs, or any other equipment. You should bring them. As I said before, we have 3 test beds. The first one is a communication test bed with a geosynchronous satellite with edge capability. We presented that in the previous info day. The second one is a low Earth orbit constellation, again with edge capabilities. Again, we presented the previous time. And what we're going to present today is a LEO-based narrowband IoT testbed for onboard edge AI data processing. So for your submission, you need to read carefully the guidelines for applicants because we also describe the eligibility criteria in there. The technical annex because we describe all the components of the agrarian. And we also have another document, frequently asked questions, that we have answered them. We had with the today 2 info days. You could subscribe there to receive the news. You need to choose one testbed. So this is a difference from the previous open call. In the previous, you had to choose one testbed and one pilot from the agrarian pilots. In this testbed, you are not connected to the agrarian pilots. You only need to choose one of the 3 testbeds, but only one, not 2 or more. In your application, you will also have to check what kind of application or use case you are bringing. So you will see 3 options like livestock, crops, and other. So please tick according to your use case. But again, it's not like that you have to choose from agrarian. It's in what sector you are falling under. And finally, just to remind you that we accept submissions until the end of the month. And for the submissions, you should visit our website in order to have access to all the documents and the submission link. So that was it from me. Let's continue now to the presentation of Testbed 3, which is from SATELIOT. Diogo, I'm stopping sharing and the floor is yours.
Thank you, Michael. Well, good morning, everybody. I hope everybody hears me well. Let me share my screen. Well, you see my screen, right? Okay,
yes,
perfect.
thank you.
Thank you. So here I'm presenting a testbed 3 that we call Satellite Edge AI Compute Emulation Testbed. This is a joint work between SATELIOT and Ubotica. So what are the objectives of this testbed? This testbed, we simulate the provisioning of non-terrestrial NB IoT communication. So it's narrowband IoT. So we focus on IoT applications, and we need to send very small messages. Actually, to be very precise, around 200 bytes is what our link allows us to send. So we are not talking here about videos or high demanding, like in bandwidth data. And we are simulating here a low Earth orbit satellite constellation. And with the capabilities of Ubotica, we are able to also provide onboard AI capabilities to this testbed. So our idea here is to enable deep learning inference on board the satellite on the edge. And as I mentioned, we emulate this dual payload where we can have deep learning inference on Earth observation imagery, but also to send through the short methods the IoT data. And our goal here is to allow Open Call developers to leverage these two data source, the Earth observation imagery with the IoT data, to create new applications and help agriculture to improve efficiency. So I'll quickly just show the architecture of our testbed. So our testbed, we simulate real hardware of satellites in our lab. So we use hardware that has a similar performance with what we have in orbit. You will not be communicating with in-orbit satellites in this open call. There was a doubt that some people had in the other open call. What we have is a simulation in the lab, but with very similar hardware where we can run these applications. So what we have here, we have a simulated IoT device that this will be communicating with your sensors. We don't have sensors in the lab. We need to communicate our in-lab IoT device with your external sensors in the fields. We're gonna do that through a VPN access, where we're gonna forward the data from your sensors, your device, into our IoT device in the lab, so we can simulate the transmission of this narrowband IoT data in our link with our satellite or with our simulated hardware. Here you see that in the yellow boxes, we have some container orchestrator agent. That means that we have the options, if needed, to run edge applications also directly on the IoT device or on our simulated IoT device. Although the focus of this open call is to run the AI application on board the satellite with the help of the hardware provided by Ubotica. So the open call developer will connect with our IoT device through this VPN. The information or the IoT data will be sent to the satellite. In the satellite, we're gonna also have our orchestrator able to deploy the AI models. Soon I will let Ubotica better explain exactly how this deployment will work. And on the ground, we also have the option of having another orchestrator agent where we could run applications on the cloud if the application requires. And then once this data hits the ground or hits our core network, we are able to forward this data either to the Agrarian Center storage, as Michael was showing the whole Agrarian project with the EDSS and the Orchestrator. We also have a center storage where we're gonna store all the data so we can generate insights for the policymakers and also for the farmers. And also we can forward it back to the developers through another VPN in case you have any dashboard or something that you want to visualize the data that's being sent. Well, I already mentioned in the other slide, but just to bring the attention again, these IoT data and this link they're seeing between the satellite, that's it's very limited in bandwidth as we are using narrowband IoT protocol. It's around 200 bytes each message, so it's really targeting to send temperature information or some alerts after some processing Earth. So there is not a high capability. And that will be combined with the AI to be deployed on satellite. Now I give the floor to Ubotica, maybe to explain a bit the architecture and the deployment of the AI application.
Thank you very much. If you go on to the next slide as well there, Diogo, please. Thank you. Good morning, everyone. So my name is Peter O'Riordan, and I'm an engineer in Ubotica. So for this part of the testbed, what we'll be providing is the guided support to help you develop and optimize
Peter, we lost you.
models with the intention of being able to run satellites and CubeSats. Can you hear me now? Can you hear me now?
Yes, but we had a quite big interruption, so we missed a lot of what you said.
Oh, apologies. Yeah, support to help develop and optimize AI models with the target of running on satellite or CubeSat environments through our emulated testbed. So for this case, developers will have support from Ubotica to access our testbed environment through Rupia. And Rupia allows developers to send their AI application to a server in Ubotica, which has access and is connected to our AI coprocessor, an XE2. And what this provides is it is an AI model running directly on representative CubeSat hardware, and then the results will be returned back to the user who's in Rupia. They will be able to see the logs. They will be able to see the inference time per input, and so this will be quite informative when developing and optimizing their AI models and validating it for this environment. Developers will be able to remotely use this at any time. There is a queuing system, but it's still a very responsive application. And there are two methods as well. One method is to be able to fire and forget. And in this case, it's a launch the application and retrieve the results through email at a later point, or the user can remain and receive the results in the same session as where the application was launched. So the phases for this testbed and this component will be in the model development. We support quite a wide range of AI architectures and frameworks. And then through Intel's OpenVINO, we will be supporting the porting and compiling of models for our XE2 coprocessor. This is where Rupia enables the users or the open call winners to validate and verify their AI model. And then once everything is satisfactory at that point, then we will be moving on to a second step, and this is developing an application or containerizing, maybe through a Docker image, containerizing a complete self-contained process. And this may include additional helping functions or applications such as pre-processing and post-processing steps. And then to be able to deploy this entire image, a self-contained image, on a representative OBC or an onboard computer, which is connected to, yet again, our XE2 coprocessor. And they would be able to upload this complete application and then receive the results back and validate its performance. Thank you very much. I'll hand it back to you, Diogo.
Thank you. So what we put here in the next slide is basically a representative example of what could be an application. For example, if agricultural technology company is developing AI-powered livestock health monitoring, designed for remote grazing areas, aiming to improve herd management and reduce losses through the early detection of anomalies. So the idea here is that you have onboard images of observation on the satellite. So let's say the images are not sent through our link because of the limited bandwidth. And what we send through the link would be body temperature or activity levels of these animals. And then the combination of the images there here in our testbed would be probably some images stored on the satellite hardware, but in a real life application, this would be a camera on board the satellite where the data will be captured directly on the satellite. So without the need of sending this data through the narrowband IoT link, and the data sent through the link would be IoT data, would be very small data, small messages sending throughout the day. And the combination of this data that is capable of be sent through our link with the images being captured on board the satellite would allow us to provide new applications and improve efficiency in agriculture. So that's a bit of the idea. Well, I don't know if Peter has anything to add before we go to the Orchestrator and app repository.
No, I'm ready for the Orchestrator and app repository. Thank you.
Okay, thank you. Well, as I showed previously here on the architecture, you saw this yellow boxes that are referred to, and these are agents. They are deployed throughout our testbed that represents the distributed architecture of Agrarian. So now I will explain a bit better the boxes of the Orchestrator and how these applications are stored to be distributed in our system. So in this picture, we show a overview of the Agrarian system. Here you see on the left that I listed the 3 testbeds, the 2 that were presented in the last info day, and testbed 3 that we are presenting here today. So the overall idea is that the developers, in this case you, will interact with the system through a development dashboard. We plan this to be a GitHub interface where you can develop and test your code. Also, alongside you, our idea is to create a CI/CD pipeline. What I believe that will be a bit more application specific, where you can test the application and automate all this containerization process before getting the image into our system. So here we have 2 main elements: the Orchestrator and the application repository. So the Orchestrator, what it is a K3S cluster where we have the K3S working nodes deployed on the satellite, on the cloud, and on the IoT edge device. So allowing distributed computing. And the Orchestrator, what it does is basically it accesses this application repository and is able to deploy certain applications in different nodes. So we can deploy it on the satellite, we could deploy it in the cloud, and we could also deploy it on the IoT device. Also, the Orchestrator allows us, if you look at this architecture, we have this system management dashboard that right now we're creating a Grafana interface. So the Orchestrator also allows us to check for the health of the nodes, understand the memory consumption, also the CPU usage in each of the nodes, to understand if the workload should be redistributed to another node. And what is the application repository? Well, the application repository that you see here, that is the connection between the CI/CD pipeline or how the application developer upload an application to be used in our system, because the idea is that you can reuse applications, and we have all the applications upload to the Agrarian system available for the different agricultural producers. And we do that by hosting a private application repository that's a Docker registry. Right now we are using Docker images. And what we do is that after we test the application, we containerize it in a Docker image. We're going to host it in a private Docker registry and make it available to the users of the system. The overall idea is that the user can, through the Agrarian user interface, see which are the applications available, select a test bed and a node in the system and deploy this application through our orchestrator. And that's all from my side. Michael, I see that we have some questions in the chat. I don't know if we should discuss them now or at the end of everything.
Diogo, let's discuss it in the end of the meeting.
Okay. So I think I give back the floor to you, Michael.
Yes, thank you, Diogo and Peter. Let's continue. Let me share my screen again. Okay, let's continue now to the next one, which is the presentation of the projects that have been selected in the first open call. Of course, please have in mind that while the focus of the previous open call was in developing applications, so that's why it was called develop, this open call is called implementation. So we focus more on new use cases and real field data. Of course, again, we will have some applications to process all this data. We had 8 winners again with the same funded amount. We had most of them were SMEs, but we had 2 universities among them. Then in the previous call, we had 4 test beds and a data set. So here you can see in this column the distribution. You can see my screen, right? Because you can see my screen.
Yes, Michael.
Okay, because I don't see the sign. Okay. And here in this column, you can see which test bed each one chose and which use case from the agrarian pilots. And we had selected proposals from Greece, from Portugal, from Cyprus, from Spain, and from Poland. And let's go very briefly to one by one. The first one is precision livestock monitoring with AI and IO tools. The abbreviation is PROVATO, the acronym. This makes sense to, to the Greeks because PROVATO means sheep in Greek. So this is, a clever acronym. So let's go inside it. Actually, this project brings a livestock monitoring system based in some smart sensors, a mobile application that they will develop, and AI. They are working with the non-geosynchronous satellite, the low Earth orbit satellite. This was testbed number 2. They have AI-powered tools implemented at the edge node. The scope is the early detection of health issues and optimized resource use. They also provide agrarian with a data set. And they also trying to integrate all these data pipelines and cross-source interoperability between sensors, APIs, weather data sources, etc. So far the project, here you can see some screenshots from the application, from publication that this project did. And at the last bottom picture, you can see the sensor on the neck of the ship. This is a tag sensor, I guess. So, so far, they have implemented 16 devices, these sensors. They have collected environmental data. They have 4 active partners and 3 external groups, I guess partners and equipment providers. They have developed, they have started the edge application testing, the analysis of the physiological and behavioral tasks of the animals with AI models. And they have also, as I said before, they have also published a poster actually to a conference. Next one is coming from SME from Greece. It's Edge AI for lameness detection in ruminants. The target of this project is to develop an Edge AI system using that automatically detects this sickness of the sheep using computer vision. They have some edge devices that actually these edge devices provide the vision, the visual. So they later analyze and process all these visuals in order to predict and analyze the disease. They have cameras on the farm. They have also on-farm AI processing, and they produce finally, the application produces alerts to a simple web application, so the end user, the farmer, can receive these alerts. They are working with testbed number 4. They deploy the AI models on the edge computing node of this testbed, which is an NVIDIA Jetson. And the data flow is from the edge AI application to the testbed and then to the farmer, to the web application that farmer uses. The contribution is, of course, except the detection of the lameness disease, they produce also some annotated data set for this disease, and they try to transmit only the metadata for the detection from the satellite narrowband IoT system. Progress so far, they have collected all the requirements and the initial specifications. They have finalized the pipelines. They have started accessing the testbed, and for the next period of time, they will finalize the integration and all the performance measurements that they will get. Next is the WineSmart project from Portugal, again from an SME. This project uses a rover in order to extract the exact location of leaves, grapes, and diseases in order to produce accurate maps. And combining all this, they target to implement a precise spraying with an accuracy of a few centimeters. So with that, they reduce the unnecessary spraying, and they focus only to the point of interest. So here you can see in the picture this rover that they have developed. This project uses the dataset of Agrarian, so not a testbed, but we had another option that we were provided back then, a dataset, an agricultural dataset. So they get this dataset to train the algorithms to predict these disease outbreaks in vineyards. They also cooperate with one of our pilot leaders, Avipe. So they produce a data set with vineyard images from their field and some containerized AI models that we can further use it with all the previous mechanisms that we described. And here you can see some more pictures from the progress so far. They have a prototype rover. Here they can, this is how they scan the plants and they make all these precise maps. They have created a very good collection of images. They have been developed the AI models. And they are currently developing the spraying module. Next one is Gracians from an SME in Cyprus. The main target of this project is using drones, actually a swarm of drones, to monitor both the herd of the sheep and the pasture areas in order to achieve some livestock grazing management. And they combine all this to a web platform, a web application. So again, the user very easily to connect to the internet with just a browser to access all this information. So here you can see a diagram, and this is how they are integrated in Testbed 1. This is the geosynchronous satellite testbed. You can see the ground satellite node, the satellite, and the edge server. So at one side, all the data from the field, which is actually the video from the swarm, is going to the ground satellite node. Then the data are passing through the satellite and they are ending up at the edge server. The edge server runs both the application core and the web application. So all the information is analyzed here and it is exposed to the web application where that user receives all these services. Selected data, as I said before, are stored in the data storage in order later on our ADSS to receive them and make further analysis. So far, this project has make some initial work with the architecture, with the requirements, with the UAV testing. They have already make some validations and tests, mainly in the lab, and in the next period of time, they will make some further testings on the agrarian testbed. Next project is La Vaca Feliz, which in Spain it means happy cow. Another good, nice title for a project. And this project is again in livestock monitoring. They use this time not drones necessarily, but sensors and GPI devices for collecting real-time data from the animals. And by tracking all these vital metrics of the animals, like animal position, temperature, activity levels, and using the edge computing of the testbed, they also predict and produce some useful insights and some alarms for the farmers. This project again uses testbed 1 with the same way as I described before. So all the data through a VPN connection goes to the ground terminal to one side of the testbed. All the data pass through the satellite to the edge server where all the processing happens, and then we have all the alerts and the decision systems to the users. So more or less, I described all this to the previous slide. And so far, they have defined the testing scenarios. They have made some KPIs, more detailed definition. They have finished. They are about to finish the implementation and the integration of all the solution. And this month and the next one, which is the last one, they are gonna deploy the final solution in Testbed 1 and make some measurements and performance analysis. Next one, it's Vine Sentinel from Polytechnic Institute of Portugal. This project develops a mobile AI decision system, a support decision system that gets and fuses all the satellite images and environmental data in order to combine all this and produce early disease warnings and make decisions driven from the collected data. This project again uses the agrarian dataset and satellite images. It is in the case of Pilot 3, they're working with Vinegar's management. As I said before, they're developing the decision system, and they introduces the explainable AI ecosystem, which is actually a friendly and understandable way for the user to understand all the AI inference and results. So far, again, this project has completed all the pipelines with the datasets. They have collected all and produced and defined all the metrics and like NDVI for the plants. They have set the baseline for the model. They are in cooperation with 9 professional agronomists to help them in the work, and they have also published a paper in a conference. This is very useful for us as it helps very much to the communication and dissemination of our project. So suggesting or having in your proposal in KPIs that you will produce papers in peer-reviewed journals or conferences is something that it is very positive for your application. Next one is the Satellite Edge AI for Precision Viticulture, SME from Poland. This project uses CubeSat equipment for real-time monitoring and decision-making in vineyards. They use the edge hardware of the Cube satellites, and in order to detect, and they run AI models on it, in order to detect inefficiencies and other performing areas on the fields. They use the previous number 3 testbed from Cubotica, but please don't be confused with the current testbeds. As I said before, they use this testbed in order to run AI processes on board the satellite, the emulated satellite, in order to make all these estimations. And so far, they have acquired some samples from Copernicus. They have implemented and tested some AI models, and they have implemented and defined also the pipelines for all this processing. And last one is the Vinea drone from SME in Greece. This project uses drones in order to detect diseases on vineyards. Actually, they use multispectral cameras on the drones, and they are initially flying in a high altitude, around 50 meters. And when they detect a point of interest, they go closer for a closer inspection at about 5 meters. And they analyze all these visuals with machine learning algorithms to detect some diseases. They work with Testbed 2, and they follow a three-step approach, which is the identification of point of interest. They also make flight path adaptation, and they detect the issues on the plants. So far, they have made work on point of interest identifications. They can calculate the NDVI, um, some row detection, segmentation, and other procedures. They have made work on the flight plan because they try also to minimize the unnecessary flight routes. And also they have also make work on the disease detection with their machine learning algorithms. Okay, so that was it from all the previous projects. You got an idea. Of course, this open call is not completely the same. So again, we're focusing on new use cases, and we want to get real field data and the applications that they will run on our testbeds to consume real field data in order this time as both the agrarian platform and the open calls are more mature to see all a realistic data and implementation chain. So that's why we ask for real data this time. So let's see now the platform walkthrough for the submissions, and then we will try to answer as many questions as we can in this time frame of the call, and the rest of them we will answer them offline. Thank you very much. George, the floor is yours.
Thank you very much. Hello, everyone. My name is Georgis from Demokritos. Let me share my screen. So the purpose of this presentation is to show you how you can apply to submit your application on the Agrarian. The first step is to visit, of course, the domain of Agrarian in agrarian.appliobox.gr. And the first time, of course, we need to go to register page, where we create our account. First, last. One moment. I have a demo email for the purpose. So we create our account by entering first name, last name, and an email that we will use for verification of account and the password. And then we'll get an email. One moment. So this is the email you will get to verify your account. And when we verify, we get the message, email verified. And then we can proceed to login page. Again, I'm using the demo credentials. So when we sign first time, we see the first screen we see is the total calls on the Agrarian. This is the first one. This is the second one that is open for submission right now. And we can see more info. We see some general information for the call, an overview, the applicant guidelines, technical annex, and the FAQs mentioned earlier by Mr. Badstatos. We can download them as a PDF. And then we can apply the call by clicking apply. So this is the main form where we give our input for all the fields needed. Okay. Here we must choose one of the test beds, as mentioned earlier. Let's choose the new test bed. And let's choose also a pilot. And then it's self-assessment and self-declaration options. Okay. So in order to submit our proposal, we need to download the templates for the proposal form and the SME declaration if needed. These are two files in a docx format, which then we should re-upload as a PDF file. We export the completed docx as a PDF file and then we re-upload it. I have a demo PDF to upload. We have to accept the terms and conditions you can read here. And then we can save draft of our proposal. And in order to fully submit, we have to click on submit the proposal. Something I didn't complete. Oh, yep. So the proposal is submitted successfully, and you can see the last time of submitted. You can resubmit as many times as you want until the end of the submission period. We click my proposals, we can see the one we submitted, and we can continue where we stopped after we saved draft or we submitted. The last menu item is the FAQs, which are being updated every time. And the last thing I want to show you is in case you forgot your password for entering the platform, you can provide the email you used for the registration. And you can get an email for resetting your password. Also, I forgot to say, after we submit our proposal, we get an email that confirms that we submitted our proposal, which is this. And lastly, the reset password email with the link to reset our password. We enter the provided email once more and the new password. And then we can log in with the new credentials. Right where we were. So that's all from me. Thank you very much.
Thank you, George. Okay, so let's continue with the questions that I see in the chat. We have some. The first three, as I see, are about the testbed. So maybe someone from SATELIOT or Ubotica would like to answer them.
Yes, here's Diogo from SATELIOT. I think I can answer some of them. Well, the first one, hi, I want to know 200 bytes data is per day or per transaction. Well, this is the maximum data, the maximum size per message. You can, depending on the application, you can send several messages per day. So we can align when you have the support of our team with the application exactly of your needs, but it's just because each message you send is limited to 200 bytes, but you can send several messages a day. Do you have a standardized format to the data on your IoT emulated sensor? Well, also not. That depends a lot of the application. Ideally, we receive the data that we can then serialize to send it through our link. But for example, right now in the Open Call one, we are working with JSON. We are receiving the information in a JSON, but the format can change as well. We can adapt once we receive it and change the format. That's something also that needs some coordination with us and the developer, but can be adjusted. Give your have limited bandwidth. Why is there EO data imagery stored on the satellite? This does not seem to be a realistic scenario. Or are you talking about public available Copernicus data? Well, exactly what kind of images that we are using, I'm not sure if that's brought by the developer. Maybe Ubotka could help me to clarify that. But in a perspective of realistic scenario.
Hi there.
Yes, Peter.
Sorry for the interruption. Yeah, for EO data, it's emulating on a satellite that is able to capture locally Earth observation imagery, in which case this would not be passing over the NB-IoT connection. It would be locally captured and passed directly to the onboard computer and processed locally. So therefore, it's not a contradiction for large data as it's a local sensor as such.
Yes, exactly. So at the end, we are just simulating, as we explained also in other slide, like a dual payload, as the satellite will be capturing the image and also sending the IoT data. Let's see the next one. I don't know if you want to take over this one, Michael. This is not very like specific for one aspect.
Yes, thank you, Diogo, for the answers, and Peter. Next one, if we are primarily interested in ready-to-use applications, or we are looking for applications that are still in development and further be developed in our infrastructure, I guess both. We just need some applications to exist in the edge server in order to consume the data through the testbed and validate the testbed and the edge processing and all this chain of process of mechanism. So both, even though I'm not sure what you mean by to become possible with our infrastructure, but yes, if you have a developed application that needs something more to be finalized and work, yes, it is acceptable. And next one, whether UK-based SMEs are eligible to participate. In the applicant's guide, we have the eligible countries, and there is also a link leading to the European Commission that describes all these countries that can participate. I don't remember the list by heart right now, but you can follow this link and answer your question. From your perspective, are potential agrarian applicants mainly about creating new innovative agricultural technologies or about demonstrating and validating existing solutions in real farming environments? Actually, both. For sure, we are asking new use cases. But also a technology should exist in order to run at the edge server. We focus more at the implementation this time and in the use case as a whole. So you just need to have an application. Next one. In use cases, there is a strong need for on-field hardware, and they're asking how the farmers will connect to the platform, etc. So this is your responsibility, and that's why we have also the option of consortium, because either the the developer of the technology or the farmer should have this extra hardware on the field, and their responsibility to transmit this data to our platform through the internet. We'll probably give you some VPN connection, but you need to have the equipment, as I said before in the presentation. Will applicants get direct technical support from the testbed teams? Yes. Is Agrarian platform like a portal towards other applications listed in a library? Or we need to have an application that processes data and delivers them into a standardized form to be presented by Agrarian platform? Agrarian platform is not just a portal, it's a whole mechanism. And you need to have an application, your own application that processes the data that you will collect from the field. And then, yes, you will talk with the developers of Agrarian also, because you need to have a standardized form in order to store this data to the data storage, in order then for us to be accessible, this data to be accessible to us. So, yes, you need to have your own application and to have a standardized data form for the data storage. Will be granted access to this presentation. We will have the video online, so you can watch the video online after today. I'm not sure about the presentations. Last time you didn't have the presentations online. We might do it for this time. It's not sure, but you will have the video for sure. Could you give me an overview of the key differences and unique focus areas of the three testbeds? They are all described in the technical annex, so please read them, read all this info carefully. And you can also watch the previous info day that we presented the two testbeds, and you can also watch again this info day that we presented testbed number 3. Thanks for the webinar. The projects, the open calls, you mean, end in September, but some crops are for later, yes. So in case we will need some extension, you can get some extension, but not a long extension, because Agrarians also is ending after September 2026. So yes, you can have some extension, but not much. Some projects funded in earlier calls are quite similar to what we are proposing. In such cases, will new proposals still be considered if they show clear added value, or are they likely to be ruled out as duplication? yes, you can propose. I guess they will not be quite similar. As you said, you will show the added value in relation to the previous one. So yes, you can do it. And I see, hi Diogo, so I guess this is for you. Is there a limitation in the downlink message from satellite to ground station? What is the size and format of insight?
Hello. Well, the format of the insight, I think that can be coordinated as well. We don't have a specific format that you need to send your insight, similar to the uplink or to the link to the satellite. This, depending on the format we receive, we can format it and what is most efficient for us to transmit. Well, the downlink here we have a better bandwidth than the uplink, that less constrained. We could aggregate some messages, or even the insight could be bigger. To be honest with you, I don't know the maximum by heart right now, but it's something in around megabytes already here. So this insight could be bigger, but I'll also try to maybe come back to you through the portal, Michael. I don't know how they share this information, if we confirm internally. Does this need to be through the platform, I assume, not the official email from Agrarian?
Oops. Yes, Diogo. Yeah.
Yeah, okay. So we can maybe come back with a more precise size for the downlink, but this would be in the order of megabytes. Would be a bit better than the uplink that we have directly with the LT device.
Okay, thank you, Diogo. In case you have further questions or you need more clarifications, please send your email to the support email of the Agrarian Call, and we will try our best to answer you. Okay, so that was it. Thank you very much for participating. I would like to wish you best luck and results for your proposals. And we are here through the support team to support and answer all of your questions until the end of the month. Okay, thank you very much. Bye bye.